we are now being asked to solve this system using substitution. Now, since I see that y is by itself without a coefficient in the first equation, I would like to isolate that in the first equation and rewrite it as y is equal to negative 2x plus 2, and use that to substitute into the y position in the second equation. The second equation now becomes 5x plus 3 times input is equal to 9, and that input is negative 2x plus 2. So we will do some distribution and solve this new equation. We have 5x minus 6x plus 6 equals 9. Combining together, we have negative x plus 6 is equal to 9. Therefore, negative x, let me leave that up there, negative x is equal to 3, and dividing each side by negative 1, we have x is equal to negative 3. So that is part of our solution. Now we need to find the y value that corresponds to this x value, and I'm choosing to substitute it into that red equation up above. This will give us y is equal to negative 2 times the negative 3 being input plus 2. Y then is equal to 6 plus 2, which is then equal to 8. Our solution set for this problem is the point negative 3, 8. This time we're being asked to use the addition method, also known as the elimination method, to solve this system. However, the equations are not cleaned up the way we'd like them. So let's put these into a nice, neat, standard form. For this first equation, let's distribute on the left. This will give us negative 3x plus 3y is equal to y minus 14. Now let's rewrite this on the next line in a nicer form, subtracting the y on each side. We will have negative 3x plus 2y is equal to negative 14. And this second equation being brought down, put in standard form, is 2x minus 7y is equal to negative 2. What we see here in blue is now our system that we're going to be solving. We need to choose a variable to eliminate, and since the least common multiple of negative 3 and 2 is 6, as opposed to 14 for the y coefficients, we're going to choose to create 6 x's in this first column, so to speak. So let's multiply the first equation by 2 and the second equation by negative 3. Our first equation becomes negative 6x plus 4y is equal to negative 28. And our second equation, everything being multiplied by negative 3, sorry, I should be multiplying by positive 3, will give us 6x minus 21y is equal to negative 6. I wanted to have opposite signs for these 6 x's so that they would cancel each other out. Now, adding down, we have negative 17y equals negative 34, and we can easily see that y is equal to 2. Now we need to go back and solve for x, and I think the easiest place to substitute in, would be right here, so we can solve for that x with the 2 in front. This will give us 2x minus 7 times 2 is equal to negative 2. 2x minus 14 then is equal to negative 2. Adding 14 to each side, we have 2x is equal to 12, and therefore x is equal to 6. Our solution set is the point 6, 2 for this problem. Okay, we have another system to solve, and we notice that the second equation is not in standard form. So let's line these babies up. That second equation is going to become 2x plus 4y is equal to 8. And I'm just thinking to myself, if we were to, instead of just bringing the first equation over, let's divide by 2. That will give us negative 2x minus 4y is equal to 1, and that will help us to eliminate the x's. But it turns out we're eliminating the y's also, and we get 0 is equal to 9. When you get a false statement such as this, we have an inconsistent system, and so our solution is the empty set. There is no solution to this problem.